Hi everyone, it's me, Miss B, and in this video we're looking at the Unit 2, Lesson 9 cumulative practice problems from Illustrative Math Algebra 1. So let's jump in. The directions here are to justify your thinking as you answer each question, so I'm going to do my best to make my answers show what I'm thinking, and what I'm thinking is I'm going to be speaking to you, so hopefully I'm going to have my answers show a little bit of my reasoning, just in their written form as well. So let's start here. A car has a 16-gallon fuel tank, and when driven on a highway, it has a gas mileage of 30 miles per gallon. That's also called fuel efficiency. And it tells us the number of miles the car can travel for a particular amount of fuel. So on 1 gallon of gasoline, that's in this case. And 30 miles per gallon means if it has 1 gallon of gasoline in the tank, it can travel for 30 miles of distance. So after filling up the gas tank, the owner of this vehicle, or the driver, I guess, gets on the highway and drives for a while. So how many miles has the car traveled if it has the following amounts of gas in the tank? So I'm going to underline or highlight, maybe I'll just highlight, some important information that I see from this. So generally, most things with numbers are going to be important. So I'm going to say that it has a 16-gallon fuel tank is probably important for us. That's the maximum amount of gallons it can hold. And then I also see that it goes, and it has 30 miles per gallon. So how many miles has the car traveled if it has the following amounts of gas left? So if it has 15, we can do some arithmetic here, and we can say the 16 total that it might start with. My pen here is a little bit thin. The 16 total that it started with minus what it currently has is the 15. And then however many gallons that is, we know it would have gone 30 miles for each one of those. So whatever that number is, I'm going to multiply that by 30. So in this case, it is 1. So 1 times 30 means 30 miles. For the next one, if we have 10 gallons left, we're going to do a similar thing. We're going to do 16. We're going to subtract 10 to see how many gallons they used, and multiply the number of gallons used by the 30 miles per. So that gives us 6. 16 minus 10 is 6. And times 30 would be 180 miles. So let me put some boxes around my answers here just to make it easier to read what my answers are on these questions. So always good to do that on a piece of homework or a test where your teacher has to read through and find your solutions. So now if it has 2.5 gallons left, we're going to do the same thing. Take 16, subtract the 2.5, and see how many were used, and then multiply that by 30. So in this case, 16, when we subtract 2.5, is going to give us 13.5. And a lot of times when I'm doing that subtraction, I just count backwards in my head by that many numbers. So I'm going to count backwards 2.5 times. So I would say, starting at 16, I would say 15, 14, and then 13.5. And that's just kind of how I do the mental math. I don't know if that is how you guys do subtraction when you have to do it in your head, but I just count backwards or I count forwards, however many I have to add or subtract. So we still need to multiply that by 30. And so 13.5 times 30 is going to give us 405. I'm going to show one more step here. I'm going to show that this is 13.5 times 30. So that I actually did that subtraction. And then this should be 405 miles. And put a box around this one. Okay, so that's part A of question 1. Question 1 is kind of long. It takes up most of the page here. And I know that on this homework, it shows next is like number 10 down there at the bottom. But when you do go look for the answers and things, they will be numbered correctly, I believe. So we just have them in different orders on the assignment. So for part B, we want to write an equation that represents the relationship between the distance the car has traveled in miles, D, and the amount of gas left in the tank in gallons, X. So D is distance, X is gallons of gas. So just looking at what I was doing, I did some subtraction here, and then I multiplied. And that was equal to my distance. So I'm going to start by just saying that not X, D for distance is equal to, because I know I had the equation in the top part designed to give me the distance. So now what I did was I took, in parentheses, 16, and I subtracted the number of gallons that were still in the tank. And that we're representing with X, and then I multiplied that number by 30. This is a valid equation that represents the relationship of the number of gallons left in the tank giving us the distance. Now, you could write this a couple different ways, but I would say that this is probably the way that makes the most sense. You could distribute the 30 if you really wanted to, but then we lose things a little bit, and it's easier to see in this case where the 16 and the 30 come from. So then part C, we are going to figure out how many gallons are left in the tank when the car has traveled these following distances. So if it has traveled a distance, I want to take whatever that distance is, and I want to divide that by 30. So I am going to take 90, and I'm going to divide that by 30. Now that's going to tell me how many gallons of gas I used to go that far. But I don't want how many gallons of gas I used. I want how many are left. So I am going to start with the 16, and I'm going to subtract that amount because I'm going to have my starting, and I'm going to subtract my gallons used. So that's how I'm basically doing this one, starting and I'm subtracting the gallons that I used. And the way we're finding gallons used is by doing our distance, and we're dividing that by our miles per gallon, our MPG, or our fuel efficiency. So let's actually solve this one here. We're going to have 16 minus, and 90 divided by 30 is 3. So that would give us 13 gallons left. And we're going to use the same strategy on the next one. I'm just going to change my pen color so you can see what work goes with which question. So if it's 246 miles, I am still going to start with the starting amount of gallons, and I'm going to subtract that 246, but not the miles. I want how many miles, I want how many gallons those miles used. So we got to divide that by 30. So we're going to have 16. And then this, from what I remember, does not come out to a nice even number. So let's plug it into a calculator. So we are going to do 246 divided by 30. And I believe this is 8.2, if I typed that in my calculator right. So now we're going to actually do 16 minus 8.2. And that would give us 7.8 gallons left. So gallons of gas left. Now, part D, just like part B asked us to write an equation based on the work we were doing for part A, part D is going to ask us to write an equation to represent the work we're doing in part C. And so it does actually say here, makes it easier to find something. And so when they say makes it easier to find, let me erase this and underline or highlight more of this here. This phrase, makes it easier to find the amount of gas left, is actually mathematical code, I suppose, for saying solve for the gallons left. If they want us to make it easier to find, that means we're going to solve for that. And solving for something means that we are putting that variable on this one side of the equation all by itself and have everything else on the other side be an expression. So I'm going to start with the equation I wrote originally. And that was d equals 16 minus x times 30. Now I could manipulate that equation around a little bit, but that would take some steps. I did already use kind of a format here in part C. So we have the option of starting with this one and just manipulating it and getting x all by itself. Or I have the option of using this stuff here that I was doing for my subtraction, and just plugging in things where I'm representing others. So this was giving us gallons remaining, so I'm going to say that x is equal to, because x was our gallons remaining. And then I started both of them with the 16. And I was subtracting. And the only number that changes here was the numerator of my fraction, or the top of my fraction here. And that number is where I put the distance that was traveled. And we're dividing that then by 30. So if I'm able to do some of the arithmetic myself up top, then I can translate that into an equation. And that's also what we would get if we took the equation from part B and just rearranged it and solved for x. So that's it for question one. Question one was kind of long, but now that puts us on to question two. So for question two, we have the area of a rectangle is represented by the formula A equals LW. I'm going to highlight that. That's a formula where L is the length and W is the width. And the length of the rectangle is 5. That also sounds like it could be important. We want to write an equation that makes it easy to find the width of the rectangle. So that is code word for solve for the width. And that is also what you have on your hint over here. The hint is to solve for W. So I'm going to start with A equals L times W. And they use like this italicized version of L. I have a hard time writing an L that's actually like, it looks like an L instead of a 1. And so traditionally in math, you would write, if you're handwriting this, like a cursive version of a lowercase l, since it is lowercase l here. So if I want to get W by itself, I have in front of my W an L that's being multiplied by it. So we just want to undo that. We want that L to cancel out and disappear. But we have to do that operation to both sides in order for it to be valid. So in order for this to be a valid move or a balanced move, we have to do that operation to both sides. That's going to leave us with W. And then on the other side from W is going to be the area divided by the length. So, and if they told us the length of the rectangle is 5, we could also represent this as W equals area divided by 5. So we have two options here. If we know the length as a certain number, we can plug that in, but I like to start with just the basic equation first, and then plug numbers in afterwards if that's available to me. So for this next one, we are going to look at problem number 10. So yes, it's out of order, but they're numbered correctly on the homework solutions document. So they're just out of order on here, but if you go on the homework solutions document, you'll be able to see this one as number 10. So for number 10, Lynn says that a solution to the equation 2x minus 6 equals 7x must also be a solution to the equation 5x minus 6 equals 10x. So we want to write a convincing explanation as to why this is true. So why is this true? And the easiest way to explain that is if there is a valid move that would turn the first equation into the second one. Because any valid or balanced move would create an equivalent equation or one that has the same solution. So they're giving us that hint here by saying must also be a solution. This means we're looking for equivalent equations. So I'm going to write that little note here. And I know that if I use a balanced move, I can do that. So if we look closer at our actual numbers and everything here, you'll notice that the -6 or the -6 on both of these stays the same. So it doesn't look like I am multiplying anything or that I'm doing anything with the 6, but it's the numbers on both sides that have x that are changing. So we have to figure out what's happening with those. And it looks to me this 2 is changing into 5 and the 7 is changing into 10. This looks to me like we just added 3x to both sides. So we can say there's not a ton of room here, so I'll try to write it over in this section. I'll write it in blue so it's not going to run into my red writing here. So we can say if the same number is added to both sides, it creates an equivalent equation. I don't need to capitalize that. Equation that has the same solution. And then we can say adding 3x to both sides of the first equation. Or you know what? We can say just both sides and we can write the equation here. That way we can maybe save some space. This was 2x minus 6 equals 7x creates 5x minus 6 equals 10x, so 5x minus 6 equals 10x. So they must have the same solution. And even though this seems like it's a little wordy for an explanation, this is kind of explaining the principle behind it first, saying, well, obviously, if we add the same number to both sides, it should create an equivalent equation that has the same solution. And then demonstrating how that principle applies to this situation, that in this case, we've added 3x to both sides. So if we're going to create a convincing explanation, we need to be telling whoever we're convincing what the mathematical property is, instead of just assuming that they can make that jump themselves, because they might not know. So that's going to bring us to the back side of our homework, or the next side of our homework. I think we actually have 3 pages here. Yeah, 3 pages here, out of order, but yeah, in the correct order on your homework solutions document if you're trying to check your answers. So question 3, Noah is helping to collect the entry fees at his school's sports game. So it doesn't tell us which one, but that's fine. Student entry costs $2.75 each, and adult entry costs $5.25 each. And at the end of the game, Diego collected $281.25. We want to select all equations that could represent the relationship between the number of students and the number of adults and the dollar amount they received at the game. So I'm going to write an equation first that would make most sense to me. I like to use a total, and then that's equal to the sum of the 2 different pieces. So the total amount of money he collected is $281.25. And how did he get that amount? It was, and they're using A and S, so we're going to say it's $275 for every student plus $5.25 for every adult. This is what I would create to start, but now we want to find essentially everything that is an equivalent equation here, because none of these actually look like this. However, I can see if I have a balanced move or a valid move that I can do to create those equivalent equations. So looking at this first one here, all those numbers look right, or look the same. The only thing that's different is they have subtracted 5.25a on the left side. And since it's missing here, yep, they subtracted that from both sides. So A is actually going to be a correct answer for this. And then I would say, I'm just going to write underneath, since I'm supposed to show my thinking, that it is minus 5.25a, and that is both sides. So that was the move. B has some things here worked out. So actually, there's a couple things here. I see one, I know I'm like skipping past B, but we'll come back to it. This one here looks just like the one we just selected, but there's one thing different, and that is that they have the S attached to the 5.25. So that should not be true. And actually, there's 2 things different. A doesn't have a coefficient of the 275 on it. So that doesn't sound right to me. Those are not balanced moves that would get that for us. So I'm going to immediately cancel that one out. And likewise, the one below it also has 275 attached to A, but we should have 525 attached to A. And it has the variable for S just over here all by itself. So doesn't look like that one's going to be a solution for us either. And the one even below that looks a little bit more similar. So let's check and see if there's anything wrong with this one. We have the 281. 525 has the wrong variable on it still. The only thing that's different was they changed this from minus to plus. So that's still not enough to fix that issue. And it's not going to be equal to just A. So let's cancel this one out. So we're able to eliminate all 3 of those for pretty similar reasons. But let's take a look at B. Now I could just try to reason through this, but it looks like they just solved for A. So I could take what I have here and walk through the steps of solving for A. So I think I'm going to do that. So I want to get A all by itself, which means I have to deal with this 2.75s, and then I have to deal with the coefficient. I always like to deal with the other terms first and moving them away from the variable I'm trying to isolate. I also like to identify the variable I'm trying to isolate first, and that makes sure that I don't move that one on accident. So I have to move the other pieces. We're going to subtract 2.75s and 2.75s from both sides. So if you need to, you can draw your barrier line here at your equal sign. These two on the left don't add up, so we're just going to leave it as 281.25. I gotta move that over. I didn't have enough space. Minus 2.75s. That's going to be equal to just 5.25a. Now I don't have to keep highlighting it, but it does help me see like what is remaining. So the only thing remaining with a is the 5.25, and since that's being multiplied, we need to do a step where we divide by 5.25, and that will make it cancel here. But we have to divide everything here by 5.25. And we can simplify those separately. So I'm going to say that on the right-hand side, the only thing left is a. But I can actually separate this into two things. I can call this 281.25, and I'm going to divide that by 5.25. And then I can say that I'm subtracting 2.75s over 5.25, because something tells me, yeah, they actually do have, so I was like, that looked familiar. They do have that in this answer here. So we very may well get this as our answer. Let's actually simplify this part and see what number that comes out to be. So 281.25, if I divide that by 5.25, I am going to get 53. They have 53.57. That's actually what we would round this to, because it goes on 571, and then there's more to it. We can round, and then minus the 2.755s over 5.25 is equal to a. Now the only thing that's different about ours from this one is I have a on the right-hand side and they have it on the left. But because these two things are equal, it is perfectly acceptable to just swap the two sides completely. So B is also an answer. And hopefully that explanation was helpful, because sometimes it's a little difficult to see where some of these equations come from. So that one gives us B. That's going to bring us to question 4. We have an equation here. So B equals pi times r squared times h is an equation to calculate the volume of a cylinder, V, and r represents the radius of the cylinder, and h represents its height. Which equation allows us to easily find the height of the cylinder because it is solved for h. So here they actually spelled it out. I was telling you guys that if they say easily find the height, that means solve for h, but hey, because it is solved for h, so they want something solved for h, immediately I know h has to be by itself. So if we just looked at where is h in my first option, h is not by itself. In my second option it is, in the third option it is, and in the fourth option it's not. So right away we can cancel out D and we can cancel out A. So here we have two options. We're either going to have H equals V minus pi r squared, or we're going to have H equals V divided by pi r squared. So let's take a look back at the original equation, because we want to know, should we be subtracting or should we be dividing? Now, these don't have any symbols in between them, So it is implied that we are multiplying. If they had an addition symbol between the h and the pi r squared, then we could subtract. But we don't, so we are going to have to divide to undo this multiplication. So that means that our answer here is going to be C. Oh, I did not mean to make that an oval with the center filled in. Let's we should erase some of this. Oh, there we go. Okay, it's erased on that screen. So we're going to have C as the correct answer, and then let me redo some of my crossing out here. And so that's question 4. Question 6 is working with a tank and some volume of water in those tank. So cubic meters V is how we are measuring it. So we're measuring in cubic meters, and that represents the volume. So this is V on the right, the volume. And then for a certain number of minutes, and they're going to represent that with the variable T I see down at the bottom. So I'm going to represent T on the left-hand side. They want to know which equation could represent the volume of water in cubic meters after T minutes of water being pumped out. So we probably want to start with our original equation, which would mean, or I'm sorry, not our original equation, our original volume. So that means we're going to start with the information we have up here. If it's been pumping for 0 minutes, it has 30 cubic meters of water. So we're going to start with that 30. And I would be subtracting a certain amount every minute. So down here for choices A, B, C, and D, I see that I have 30, and I see that I'm subtracting some stuff. But I have a couple things with T squared. I am not actually going to divide by, or I'm not going to use T squared because this is just minutes. I don't have a reason to multiply minutes by minutes here. So we can cancel out or cross out C and D as options right away. Now, what we want to check then is what our rate is. So I want to see how these numbers are going. These look like they're increasing by 5, and that pattern seems to stay the same for each one. Now, on the right-hand side, 30 to become 27.5 is 2.5, so it's decreasing by 2.5. And this looks like it is decreasing Oh, you know what? I canceled out some stuff right away, but this might actually be faster. I was thinking that this is going to be a cubic volume, but it looks like I'm subtracting a different amount each time because here, this is missing 7.5. And for the next one, 20 to 7.5, that's going down by even more. That looks like 12.5, but I'm going to double check. 20 minus 7.5, that is 12.5. So I was incorrect in my assumptions here. That is why checking always helps. So I have something here that is changing. And I want to know, I guess, what my scale factor is here. Because, or maybe not my scale factor, but I want to actually plug some of these numbers in and see if they work. And that's probably going to be the best way to do it. Since it's not consistent, I am actually going to change my answer to cancel out A and B because those ones are linear, meaning that these numbers would be the same. So we're going to say that this is not linear, just as a note to ourselves. So it's not linear because those numbers are different on the left and on the right. They're changing at each step of 5. So we can plug some numbers in here. If we plug in 0 and 30, 0 and 30 is going to work for every single pair. but it's not necessarily going to work for some of our other numbers here, like maybe 10 and 20, are not necessarily going to work for all of these. So let's plug in 10 and 20 here. And so I'm going to use 10 comma 20, and this is t and v. So I want to know, is 20 equal to 30 minus 0.5 and 10 squared? So let's do that one first. 10 squared is going to be 100. So this would be 30 minus 0.5 times 100. And 0.5 times 100 is 50. So is that equal to 30 minus 50? No, because that's negative 20. So no on that one, which tells me it's probably going to be the one below it, but we're still going to check all of our answers. So we're going to say, is 20 here for volume equal to 30 minus 0.1 times 10 squared? And this is going to be 30 minus 0.1 times 100. And if you do 0.1 times 100, you get 10. So this is now 30 minus 10, and that gives positive 20, which works. So this one is our answer. So yeah, I went into that making some assumptions and definitely proved myself wrong by checking what I was changing by on each side, and it is definitely not linear. So always good to do other things to check your work, just like that, because I make mistakes too. And but luckily, doing my work thoroughly means that I can catch them before I actually just like submit an answer or upload a video. I don't always catch all of them, but I try. So that's going to take us on to the third page of the homework, which fortunately is the last page. We're going to do questions 7, 8, and 9. And there is a little note down here at the bottom. Yes, the problems on the homework are out of order or numbered wrong, but if you check, but when you check the answers, problem number 2 is number 2, and number 10 is number 10, etc. So there was a little note there telling you that, like, yes, we know it's numbered incorrectly. That's not an error. That was just so we could fit it. So we didn't have things on like 4 pages instead of 3. Okay, so question 7. A catering company is setting up for a wedding. They expect 150 people to attend. They can provide small tables that sit 6 people and large tables that seat 10. So those seem important. I'm going to say small table. Ooh, that's a little small. Small tables that seat 6 people. And we'll say large tables that seat 10 people. Those are my 2 different things being provided. So we want to find a combination of small and large tables that seats exactly 150. So let's think about a strategy for this. Exactly 150. This ends in a 0. And 10 people would help us to end in a 0. But really what's going to be a problem is I need somehow 6 to give me a number that ends in 0. So I need a number of tables that would work for 6. So I'm going to start with just the number I know that works first, which is 6 times 5. So it's going to be basically 6 people at each small table, and if I had 5 of those, that would give me 30. And then I need 120 more, so I can use the large tables for that one. And I can say 10 people, and I need 120, so I can use 12. So I can say 5 small and 12 large. This is not the only combination, but it's one of them. So you could do a couple other ones. I want to say another one that works if you check on the solutions paper is 10 small tables and 9 large tables. So you could do 60 and 90, but I just like this one, mostly large tables and then a couple small ones. So we want to let, so for part B, sorry, I'm getting ahead of myself. We want to let X represent the number of small tables. So X is the number of small tables and Y is the number of large tables. We want to write an equation to represent the relationship between X and Y. So I'm going to say, similar to kind of what I have up here, I'm going to use this format where I'm doing 6 times that number and 10 times that number. But I didn't show everything here completely. I showed what those are equal to. And I know that that was supposed to add up to 150. So I am going to say that we have 6 times X. We're going to add the 10 times Y. And this is supposed to create 150 seats. Then we want to explain what the point 20, 5 means in this situation. So we want to interpret this in terms of X and Y. Write this a little smaller, X and Y. So that means 20, 5. So that means 20 small tables and 5 large tables. So they want to know, is the point 20, 5 a solution to the equation you wrote, and explain your reasoning? So let's actually just plug this in. We want to know, is 6 times 20 plus 10 times 5 going to equal 150? So I'm going to put a little question mark above this because we're trying to figure that out. And then we'll show our work. So 6 times 20, 6 times 2 is 12. This will give us 120. And then 10 times 5 is going to be 50. So plus 50. This is not going to be equal to 150. It's actually equal to 170. So no, it makes 170, not 150. So since it does not make both sides balanced or equal, it's not considered a solution. That brings us then to question 8. We're almost done. We're getting there. Which equation has the same solution as 10x minus x plus 5 equals 41? Okay, I'm going to try to simplify this as far as I can, and generally that will show us some solutions here. So it does look like some of them are addressing this as 9x, and I know that if I combined those like terms of 10x minus x, this is really like 10x minus 1x. There's like a little invisible 1 that lives right there, and so this would be 9x plus 5 equals 41. So let's check. Is that one of our answers? 9x plus 5 equals 41. It absolutely is. That's D. And since this says which equation, that means there's only one answer. But we got that 9x by combining these two terms here and leaving everything else alone. That one was surprisingly nice and short. Okay, oh my gosh, there's A, B, C, and D here, but I think we can, it's multiple choice, so it's not like part A, B, C, or D. So let's look through this and then read what they're asking us and then maybe go back. So Noah is solving an equation and one of his moves is unacceptable. All right, so an invalid move or not an acceptable move, not a balanced move maybe. And here are the moves he made. So he has the original equation, applies the distributive property, combines like terms, subtracted 8 from both sides, and divides each side by x. Now they're telling us that the divide each side by x step is unacceptable. So they want to know which answer would best explain why we shouldn't divide by x. So I know that one of the things one of the things I think of when I think about an invalid move is that we can't divide by 0. And that's the solution we're going to go with here. Because, and that's going to be B. When you divide both sides of 2x equals 6x by x, it could lead us to think that there is no solution, when in fact that solution is x equals 0. So, yeah, x equals 0 is the answer here, because 2 times 0 is equal to 6 times 0. Or, yeah, it basically leads us to no solution, and we shouldn't be dividing by 0. So when it is 0, that sort of move doesn't work out well. When I have two terms, so what I would do in this situation with 2x equals 6x, instead of dividing by something, I would put all of these terms on the same side. So I would move 2x over by subtracting it instead. And then I would end up with, let's write out here what I would do instead. So I would subtract 2x and minus 2x. That would leave us with 0 equals 4x. Now that all of my terms are together, it's safe to actually divide by that coefficient. So you would then divide by 4 on both sides. And that's how you would reach that 0 is equal to x as your answer. So it is possible to have an answer here, and that answer is 0. But if we divide by x, it removes that possibility of us actually seeing that. So the answer is B. And that is all for this homework. I know I just said that is all, like that was nothing, but that was a lot. So I appreciate you hanging in there with me. Hopefully you just went through the parts that you had trouble with. But yeah, thank you for sticking with me. This is the cumulative practice problems, or the homework, basically, for Unit 2, Lesson 9 of Illustrative Math, Algebra 1.